So now we want to be able to go from the formula of an ionic compound to its name. So we want to refresh our memory of what we're thinking about when we talk about ionic. So far we've talked about it being a metal and a non-metal, but really when we think about the name ionic, it's really saying that it's made of a cation and an anion. Okay? And we're going to talk in a little bit where that cation and anion might not just be a metal and a non-metal. It could be something else. And I'll introduce that later. Alright, now when we talk about names, some compounds have nicknames. That's not what we're talking about. So for example, NaCl is usually considered table salt. That's not what I want you to name it. That's actually sodium chloride. So we're going to use the scientific name. Okay? So we're going to write the systematic name by simply naming the ions. So we want to look at what is the cation and what is the anion, and follow those rules. So we'll have rules for the cation, rules for the anion, and then we put those two parts together to get our full name. So the cation could be one of three things. The first option is it could be a metal with an invariant charge. So invariant means does not change. So, put either. So it does not change. So the way that we would name this, if my cation is a metal with an invariant charge, and I'll talk about in a second how do I know if it's invariant or not, but if it's a metal with an invariant charge, then the way that we name this is it's just the metal name. I don't have to specify the charge because it won't change. My second option is it could be a metal with a variable charge. This means that the charge can change. So if the charge can change, I need to be specific on what that charge is. So whenever I write the name of that cation, it's going to be the metal name, and then in parentheses I write out the charge. Because I have to be specific on what charge it is, since it is a variable metal. The third option we're going to have here is if it's what's called a polyatomic ion. And we're going to get to those in a little bit, but I want you to be aware that there is a third kind. And when we get to those, these guys, once you have the polyatomic ions memorized, then to name the cation, you just look at the polyatomic ion, figure out what it is, and it's just the name of that ion. So naming the polyatomics aren't too hard, it's just memorizing them. So those are my three choices for a cation. So it could be a metal that has the same charge every time, a metal whose charge can change, or it could be a polyatomic ion. So it's not just a simple metal. Now the anion has only two choices. The anion could be a nonmetal, and nonmetals always are invariant. So you don't have invariant for nonmetals. They're all invariant. So we have the same rule for nonmetals. So for nonmetals, we're going to take the stem of the nonmetal name plus the ending IDE. And I'm going to work through some of this too, okay? And this is just an intro. So that's the first option for nonmetals, for anions. Anions could just be a simple nonmetal, or they could also be a polyatomic ion. And if they're a polyatomic ion, it's also just the name of my ion. Alright, so let's talk about the cations a little more, specifically parts 1 and 2. How do I know if the cation is invariant or if it's variant? So let's look at that. So metals with invariant charge, the ones that are going to stay the same. So these are metals whose ions can have only one possible charge. And this is going to be your group 1A and 2A. So these metals here, not hydrogen, he's not metal, all these metals are always going to be a +1. All these metals are always going to be a +2. Over here, in these columns, some of them are invariant, some of them are variant, okay? So it depends on which one. Aluminum is always a +3, but tin and lead can change. So it depends on which one we're talking about, okay? For metals with variable charge, these are usually my transition metals. One of the reasons we want to think about that is because they can do those rearrangements. They could pull from the s orbital. You can also pull from the d orbital. And so that's why transition metals are able to have variable charge, because they have those d electrons and that they can rearrange. So these can have more than one possible charge. So the way that we're going to determine their charge is they're going to be determined by the charge on the anion. So we look at who they're paired with. So depending on who they're paired with depends on what they're going to be. So the anion is going to determine what the metal charge is going to be. So the way that we're going to name this guy is it's going to be the metal name and then the charge in parentheses. But specifically the charge needs to be in Roman numerals. Okay, so Roman numerals, that's the 1, 2, 3, 4, 5, 6, 7, and that's pretty much as far as you get. Okay, so Roman numerals. All right, so let's look at the nonmetal. So for the anion, if it is a nonmetal, then we just look at, we said that the way that it's named is the stem of the nonmetal name plus the ending IDE. So carbon is the nonmetal, so it'd be carbide. Silicon, silicide. Nitrogen, nitride. Phosphorus, phosphide. Oxygen, oxide. Sulfur, sulfide. Fluorine, fluoride. Chlorine, chloride. Bromine, bromide, etc. You could go all the way down. Okay, and this is just some examples. Now you might be saying, well, if it's oxygen, why is it an oxygenide? That's kind of hard to say, okay? So part of it is learning how they like to be structured with the stem and then stem of the nonmetal name and then the ending IDE. And then the way that we get the charge is based on the periodic table. So for nonmetals, if they're group 4, it's -4, -3, -2, -1. So same like we did here. So for the nonmetals, it's just the group -4, 3, 2, and 1. So you could look at any of these and see iodine is iodide. Selenium, seleniide. So you can look at any of them and get the IDE endings for those. All right, so now let's start looking at doing the names from these formulas, okay? And we'll start that on the next lecture.